Dear friends, welcome to the lecture of partial differential equations. We are studying non-linear partial differential equation of order 1, and in that we are studying different standard forms. So today we will study standard form 4, and that is after writing the form and the method of solution, we will solve the problems on this. So this PDE is of the form is function of x and p. F1 is function of x and p is equal to F2 function of y and q. So this is the form. There are two separate functions which involves x and p, and second function involves y and q. So we may suppose this as 1. Now the method of solution of this. Because these two are equal, we can assume these two are equal to certain quantity that we will assume as A. Let function of x and p, F1 of x and p is equal to F2 of y and q is equal to A. Suppose this, where A is an arbitrary constant. Now we shall we can solve these equations for P and Q. Solving these for P and Q, we get suppose from this the value of P will be, say, function of x and A. So take F1 of x p is equal to A and find P from that. And suppose that is function phi1 of x and A, and q as take F2 is equal to this A and solve this and find the value of q, and suppose that is phi2 function of y and A. Now after getting P and Q, we have dz by total differential. Dz is dou z by dou x into dx plus dou z by dou y into dy. Partial derivative of z with respect to x into differential of x plus partial derivative of z with respect to y into differential of y, because z is function of x and y. So this is the theorem on total differential. We have this result, and that means dz is, this is p into dx and this is q into dy. Or we have obtained the values of P and Q above, and that is phi1 of x and A into dx plus this is phi2 of y and A into dy. So thus we have obtained a differential equation, which is a total differential equation, and this can be differentiated. This can be integrated. So integrating that, we will get a solution. Integrating, we get integration of dz z, and we write the integral symbol for this. Integration of phi1 with respect to x plus integration of phi2 with respect to y, and plus a constant where b is a constant. So this is the complete integral of the equation of type 4 of standard form 4. This is the complete integral. And what about the other integral? The general integral is obtained by usual manner. That means we assume b is function of a and then differentiate this partially with respect to a, eliminate a between these two. So that we have written in earlier forms. The general integral is obtained by usual manner, or we can write obtained as in standard form 1. There we have written the method in detail. And what about the singular integral? For singular integral, we have to differentiate this complete integral partially with respect to a and b. Now, but if you differentiate the complete integral with respect to b, what is the left side? The derivative of z, partial derivative of z with respect to b will be 0, and the right side, this will also be 0 plus 0, and this is 1. So that gives 0 is equal to 1, and that is an absurd result, and therefore there is no singular solution. So there is no singular solution. We can write the reason for this. No singular solution or singular integral. As the differentiation as the partial derivative of Ci with respect to b gives 0 is equal to 1. The left side derivative of z with respect to b is 0, and this is also 0 plus 0, because there is no b in this, so treated as constant, and derivative of b with respect to b is 1. 0 is 1, which is absurd. And therefore there is no singular solution. Only possibility of complete integral and general integral is there. So these are we can find, but no singular integral. Now we shall consider, we shall solve the problems on this type. I have written the problems here. We shall take up these one by one. First, solution of 1. The given partial differential equation is this one: y into p is equal to 2x into y plus log q. Now see, we have to write this equation in this form: function of x and p. So for that purpose, we shift this term on this side and take y common. So that is y, and in bracket what remains? P minus 2x, and other side remains log q. Further, this must be a function of p and q. P and x means y should be shifted on the other side, and that should be function of y and q. So this y is to be transferred. That is y is to be shifted on right side, and we suppose that as let p minus 2x is equal to log q divided by y, and suppose is equal to a. Say suppose this is a, and from this we solve this to find out the values of small p and small q. This implies, or this gives, what is the value of p? Equate the first and last. P will be 2x plus a, and q from this. So that will be log q is equal to a into y, and therefore q will be, take exponential, e power a into y. See, log q is equal to a into y, and taking the exponential on both sides, q will be e to the power a into y. Now, so thus obtaining, this is the procedure that we have just written. We have written this is equal to a, and then we have solved this for p, this for q, and now we have the result as total differential of z is p into dx plus q into dy. Now this is the fixed step, so we always have this, and therefore further we can put the value of p and q, and that gives dz is 2x plus a into dx plus e to the power ay into dy. And now we can easily integrate this. Integrating this, what we shall get? Integrating. We can write here. Integrating, we get z is equal to integration of this is a function of x and a, phi 1, that is function of x and a, and this is function of y and a. So that is and into dy. So just integrate this, what we shall get, and we can write the integration directly easily. So what is integration of dz, that is z, and right side integration of 2x plus a, it is 2x plus a whole square divided by 2 into 2, because coefficient of x is 2. Integration of x is x square by 2. The same formula is used here, whole square divided by 2 into 2, and plus what is integration of e to the power a into y, that is again e to the power a into y divided by coefficient of y, that is a, and plus a constant of integration that may be written as plus b or minus b. Sometimes this b is written on the left side, z plus b, and this is the complete integral, or that can be written as z plus b is equal to, so this is 1 by 4 into 2x plus a whole square plus 1 by a into e to the power ay. This is the complete integral of given equation. So this is the procedure to solve this type 4 problems. Now the second is easy, and I will leave this for you to try, because this can be x can be transferred on this side, this becomes p square minus x, and this q can be transferred on that side, that becomes y minus q square. So easily we can separate it, and suppose that is equal to a, and then find the values of p and q, and then write dz, write this dz, put the values of p and q here, and then integrate. We will get this as the answer. So please try the second problem yourself. Now we shall consider solution for third. So this third example is not of directly of standard form 4, but it can be converted to standard form 4 by using certain substitution. So we can't write easily this as, because x plus y is there, and that is multiplied to this term. Here also x minus y is there. We can't separate the function of p, q and x and y also. And therefore for this 3, 4 and 5, there should be substitution to be used. Solution for 3. The PDE given is x plus y into p plus q whole square plus we suppose this as 1. Now here the substitution we shall use is capital X for x plus y and capital Y for x minus y. Put, see, capital X is equal to x plus y, or x plus y is equal to capital X, and capital Y is equal to x minus y. And thus after using these values, now what we should have to obtain is the derivative of z, partial derivative of z with respect to x. That means small p and small q we have to obtain. Now p is dou z by dou x, and that dou z by dou x, z is actually function of x and y, but here x and y are considered as capital X, function of capital X and capital Y. So therefore to get the partial derivative with respect to x, first we should have to differentiate this z with respect to capital X and then capital X with respect to x, chain rule, and therefore this is to be expressed as dou z by dou x capital X into dou capital X by dou x. Partial derivative of z with respect to capital X and then that of capital X with respect to small x plus, and similarly partial derivative of z with respect to capital Y and partial derivative of capital Y with respect to x only. We are differentiating x with respect to x, and that is, so this we will write as it is, dou z by dou x. Notations are to be used carefully. This is capital X, this is capital Y. So here we have tried this capital X and this is small x. So this will remain as it is, but partial derivative of capital X with respect to x. See, capital X is here. So its derivative with respect to x is 1. So that is 1. And so no, or you write 1 plus. And dou z by dou capital Y. And derivative of capital Y with respect to x, partial derivative, is 1 again. And thus it is simply dou z by dou x plus dou z by dou y. And q is dou z by dou y. And that is again to be expressed like this using the chain rule for composite function. Dou z by dou x first into dou capital X by dou y. We are differentiating partially with respect to y, plus in place of y, x, here it is y. So here also. And next part, capital derivative of z with see, partial derivative of z with respect to capital Y and partial derivative of capital Y with respect to small. This is the expression for q by chain rule. And what is the dou z by dou x by dou y? Now we should have. This is again 1 because x is capital X is x plus y, its partial derivative is 1 plus, or you see this will be as it is. And what is the partial derivative of capital Y with respect to small y? It is negative 1 or minus 1. And thus this value is dou z by dou x minus dou z by dou y. And thus this is the value of q. Now we write as usual what is our dz. So further, dz we have is p dx plus q dy. Or before that we have to use these values of p and q. This is the value of p and q in the original equation, and then we have to obtain dz. So instead of this, so we will write putting these values of p and q. Putting the values of p and q in 1. What we shall get is see, x plus y, that is capital X, and the values of p and q, also the values of capital X and capital Y, into p plus q whole square. Now you may see this is p, this is q. So their addition, in the addition, this term cancels. Dou z by dou y, capital Y cancels, and this becomes double. So p plus q is twice dou z by dou capital X, and that I shall write directly. 2, that is dou z by dou x and its whole square. Next, plus x minus y is capital Y. So it is capital Y. And what will be the value of p minus q? You see, p is here and minus q. This cancels, and this is dou z by dou y. Negative of negative will be positive, that is double term, twice dou z by dou y. So that is 2 times dou z by dou capital Y whole square, and is equal to 1. So this is our equation. Equation 1 becomes, that means we can now say here is 2 square is 4. and we can transfer that 4 on the right side, and thus the equation is x into dou z by dou x whole square, and that I shall write this term as capital P, x into capital P square plus y into capital Q square is equal to 1 by 4. Now you can understand this. What we have done is 4 is shifted on the other side, that becomes 1 by 4, and we have written x as it is, and we put this value as capital P, this as capital Q, where capital P is dou z by dou x, and so this is we have done. Now next, this equation now it can be expressed in the standard form 4. Function of x, capital X and capital P, and function of capital Y and capital Q. So that can be written as further, this is x into P square is equal to 1 by 4 minus y into Q square. And suppose this is equal to A. See, now we got this form here after substitution. Originally the equation is here, equation 1, and it is not of the standard form 4, and we have used the substitutions for these two terms and converted that equation in standard form 4. Now the method follows of standard form 4. So this, suppose these are equal means they must be equal to certain quantity, and suppose that is equal to A. And from that we have to obtain the value of capital P and capital Q. So equate these two first. So this gives x into P square is equal to A, and from this we can write y Q square on this side and A on this side, and that will be y into Q square is equal to 1 by 4 minus A. Or from this will be capital P is A upon x, and then take its square root. So that will be root A into x to the power negative half. X will be at denominator, and so what about Q here? Or you may write first Q square. Q square will be, this y will be on this side, and subtraction of this is 1 minus A divided by 4 into y to the power minus 1, Q square. But we want Q, or therefore P is root A into x to the power negative half, and Q is under root of 1 minus this must be 4A. In the subtraction we take the LCM as 4. 1 minus 4A divided by 2, taking square root, and this is y to the power minus half. Thus we have obtained the value of P and Q. Now we write dz. Now dz is equal to P into dx. Terms will be now in capital. Capital P into dx plus capital Q into d of capital Y. This is dz. Now what is the value of capital P? We have obtained here, it is. That is dz is equal to, it is root A into x to the power minus half into dx plus Q is root of 1 minus 4A divided by 2 into y to the power minus half into dy. These are the values of dx, pq only we have used. Now integrate. Integrating, we get, what is the integration of dz? That is z. And now the integration is simple. It is in this separate form. So integration this with respect to x. Root A is constant. And what is integration of x to the power negative half? X to the power positive half divided by half means 2 into x to the power half, plus this is constant, root of 1 minus 4a divided by 2 is constant, and again the integration of y to the power minus half is twice y to the power half. You can check these terms and verify it, plus a constant or minus a constant, plus or minus may be written, minus b. We may write plus b also, and the solution is, now finally we have to put the value of x and y. We have supposed this as capital X and we have supposed this as capital Y. So that is z is equal to 2 root a into, this will be or we may write in under root of capital X is x plus y, and plus root of 1 minus 4a, these two cancels, and this is a root of x minus y, capital Y, and minus b. Or it may be written as z plus b is equal to twice into under root a into x plus y. We have taken these two terms in the same root sign, plus under root 1 minus 4a into x minus y. This is the complete integral. This is the required complete integral. And this completes the solution of which we have solved is third problem. Yes, we have solved the third problem. Now the solution for the fourth problem. Solution of 4. The problem is z into p square minus q square is equal to x minus y. Here also we have used the substitution because it is not in the direct form, because z is involved here. And to convert it in the standard form, we shall put the substitution as, suppose this as 1, put small z is equal to, now that should be, the substitution should be 2/3 z to the power 3 by 2. Now capital Z it must be, capital Z to the power 3 by 2. Now why this is to be selected, that will be clear by differentiating this, because we want to get the value of this, and therefore this gives, if you take the derivative of z with respect to capital Z, then that is, now you see this will be 2/3, the derivative of this is 3 by 2 and again raised to half, and further the substitution should be in terms of capital Z in terms of small z. And so what change we will do is, we put capital Z, we put capital Z is equal to 2/3 into small z to the power 3 by 2. Here it should be capital Z. And now the derivative of this capital Z with respect to x is to be expressed as, this capital Z is function of small z, and then the derivative of small z with respect to x, partial derivative. So using the chain rule. And what is the dou z by dou z here? The derivative of this, it is 2/3, the derivative of z to the power 3 by 2 is 3 by 2 into z to the power half, and that 3 by 2 and this 2 by 3 cancels. So I shall write it directly, that is z to the power half, small z. Capital and small is to be written carefully. So this is small z to the power half, and this is usual term, that is p. So z to the power half into p. And what is capital Z derivative of capital Z, partial derivative with respect to y, and that is again in the same way, dou capital Z by dou Z into dou Z by dou y, and this is the same, Z to the power half, and this is q. Now see why we have done this substitution, because So its derivative should result root z, because this will be root z into p whole square, and again this term can be considered as root z into q whole square, and then this will be converted in these two terms. So we put this in 1. So putting these in 1, we get, using these values in 1, so we shall get, you observe, so it is z into p square, means square of this, and this means square of this term, that is dou z by dou x whole square, minus, what is the second term, z into q square, and what is z into q square, square of this, means square of this term, and that is dou capital Z by dou y whole square is equal to, the right side is as it is, x minus y. So thus this is the equation we have obtained. Now what we will assume is this as capital P. Dou Z by dou x we denote by small p, and because this Z is capital, we denote this by capital P. So that is, this will be capital P square minus, and similarly this will be capital Q square is equal to x minus y, where capital P is dou Z, capital Z by dou x, and Q is dou Z by dou y. So further, now this is in the standard form 4 after substitution. The original equation was not in standard form 4. Using this substitution, how the substitution is decided? By observation only. We want zp square, and this is the square root of zp square, and similarly zq square, this will be square root of z, zq square root is z to the power half into q, and therefore the substitution is decided to be 2/3 z to the power 3/2, so that its derivative will be root z. The derivative of this is root z. And now this equation can be written in standard form. It is actually in standard form 4. So we can write this as p square minus x. We will separate this as function of p and x. That is p square minus x is equal to, and this q square is to be shifted on right side. That will be positive, q square minus y. It is of standard form 4, and thus it can be supposed to be A is equal to A, say, suppose. And from this we can write the value of capital P square. That will be x plus A. And capital Q square, that is y plus A. Or from this, capital P is root of x plus A, and capital Q is root of y plus A. After this we can write now dz. So dz is, but that z will be capital Z. Now dz is capital P into dx, but this dx is small. Only z, p, q are capital. P into dx plus q into dy. Earlier was different, that we have not used the capital Z. We have used the substitution for this function x plus y is capital X and x minus y is capital Y. But here the substitution is different, that it is used for capital Z, and therefore the equation will be of this type. You note the difference in earlier substitution and this substitution. Put the value of C, the value of P and Q, that I shall write here. This we must replace finally, that is dz is equal to root of x plus a into dx plus, and q is root of y plus a into dy. Now integrate. Integrating. The part of integration here in this form is easy. Integrating we get. What is the integration of d of capital Z? Capital Z. And the integration of this root function, that is power is half. So power becomes half plus 1 means 3 by 2, and it is divided by 3 by 2. So x plus a to the power 3 by 2 divided by 3 by 2, or that means multiplied by 2 by 3, plus similar to this 2 by 3 y plus a to the power 3 by 2. And for simplicity, we may consider the constant as in the same form 2 by 3 into b, or that now we use the value of capital Z. Capital Z is 2/3. 2/3 into small z to the power 3 by 2 is equal to, and the right side. Further, we may cancel out this term throughout. 2/3 can be cancelled throughout, and this b may be shifted on this side, or not necessary. We can keep b here and write this as plus or minus. Why? Because remember here a and b are arbitrary constant. Here we assume this as a constant. It is a constant. B is also constant. Arbitrary. It is arbitrary constant. And or z to the power 3 by 2. This is now small z is equal to x plus a to the power 3 by 2 plus y plus a to the power 3 by 2 minus b. This is the required complete integral. And this completes the solution of which problem we have solved, fourth problem. Now you should try the fifth problem yourself. So here also a substitution is required, and I have written the hint here. The substitution is capital Z is equal to log Z, because in that case, what is the derivative of log Z? That is 1 by Z, and therefore this term Z cube can be written as P square by Z and Q by Z, and that will convert the equation, fifth equation, in the standard form 4. So therefore you try using this hint, capital Z is equal to log Z, exactly similar to the fourth problem. You can solve this fifth problem. This is the answer. You may verify it. So you should solve problems 2 and 5 yourself. So this is about standard form 4, the method and problems on it. So remaining part we will continue next time. Thank you.